So today we're going to be talking about modeling exponential functions. So a few different types of vocabulary here. We have what's called a growth factor and a decay factor. Okay. In a traditional exponential function form, y equals a times b to the x, we can replace b with 1 either plus or minus the rate. Okay. So if your rate is decay, you're going to subtract it. If it's growth, you're going to add it to the 1. Okay. And that piece is what we call the factor. So the factor is when it's 1 plus or minus the r. The r itself, the rate, is just the rate. Okay, so not to be confused with the factor, they are similar, but they have different meanings, they're different things. We have 3 different main formulas that we use to do the different calculations. Okay, this is like the most standard one that you'll see used online. All right, so I want to talk a little bit about how these formulas, what they have in common, and how you can use them. This right here is what we call the growth or decay factor. This one is actually growth because it's plus. So it's 1 plus the rate. If this was decay, it would be 1 minus the rate. Okay, you can change it that way. Now, if you look at this formula and this formula, you're going to see there's similarities and differences. The only real difference with the two formulas is the r is divided by n, and the t is times the n. And we're going to talk a little bit about what n is. N is the number of times something is compounded, the number of times it happens per year. So if something's happening multiple times per year, that's where n comes into play. If that is only annually, you can choose to use this one or this formula. And then we have this formula. This formula you only use, only ever, when they say compounded continuously. If it does not say compounded continuously, you do not use that formula. Okay, so that's really straightforward and clear. If it does not say compounded continuously, don't use it. Yes?
What does P mean?
P means principal. That's the initial amount of money that you start with or amount of things that you start with. Okay? So I'll talk a little bit about what all the letters mean. E is what we call Euler's number. So E is actually not a variable, it's something like pi. Okay? And it models things happening in nature. Okay, that's what we use that base number a lot in calculations in math. Especially with logs and exponential stuff. So let's talk about what each of these letters represents. A represents the final amount of either money or people or whatever the item is. P is the starting amount, the principal, the initial. R represents the rate at which something's happening. N represents the number of times it happens compounded, and we'll talk about that. And then T is time. So when you're talking about growth or decay, this formula is set up for growth because it's plus. If you wanted it to be decay, you could make it a minus. So N, you have to find out by the context of the problem what N is. If they talk about something being annually or yearly, your N is going to be 1. If they talk about something being semi-annually, your N is 2. If they talk about it being quarterly, your N is 4. Monthly, N is good. Weekly, N is good, 52. And daily, good, 365. So that determines the N is how they phrase it in the problem. If they say compounded daily, occurs daily, yearly, those are the N's that you use based on the context of the problem. All right? And all the calculator stuff that we're going to do in here, we'll talk through it the best I can with everybody, and then at the end of class, like when we have homework time, I'll come around to everybody and make sure that you're good with the calculator stuff, just to be sure. All right. So something we have is called a growth and decay factor and rate. Okay? And you have to use these interchangeably, which can be a little bit tricky. So growth factor is what's in the formula. Okay, if the formula is already written and solved out, it's what the power is to. Okay, that's the factor. The rate is what the actual rate is. So we can convert them interchangeably from one to the other. So if this is plus, is this a growth or decay factor? Growth. Okay, you can add that in. And to convert it into first thing you got to do to get it into a factor is you got to start by converting it into a decimal. Okay, so I'm going to convert that into a decimal. You see that, what I did there? Now to get it into a factor, if it's growth, you're going to take whatever the rate is and add 1 to it. That's how you find the factor. And the reason we do this, if you're wondering, is if you take something and you take 1 and you put it to the power of something, it's not going to be anything. That just maintains what we already have. So if something's growing by 25%, the 1 maintains what's already there, but 25% jumps it up an additional 25%. Okay? Decay means you're cutting into what was already existing by a certain amount, right? So let's talk about decay. So this one's negative, which means that it's decay. But we're going to convert this one to a decimal. This one's a little bit tricky because you have to move the decimal place 2 places to the left, which means you're actually going to end up with 3 zeros after the decimal place, okay? Because you move it 2 places to the left to go from a percentage to a decimal. And then to get your factor, if it's decay, you're going to basically, because it's technically negative, you're going to add it to 1. You're going to do 1 minus whatever that amount is, 0.0005. And that's going to give you a factor of 0.0009. So decay factors will always be less than 1. Growth factors will always be greater than 1. Okay? So the next one here is decay once again. Okay. So a decay factor, we're going to rewrite this as a decimal by moving the decimal place 2 places to the left. And then to make it into a factor, we do 1 minus whatever that amount is, so 0.98. So I'll explain a little bit why that is. So with decay, if something is decaying by 2%, you're maintaining the other 98% of it, right? So that's why that's the factor. If something's growing, you're maintaining the 100% that already was there, plus the additional amount that it's growing by. So sometimes you have to work backwards when they give you a problem like this, an equation. So what you're going to do is if they give you an exponential equation and they want you to identify growth factor, all that stuff, you're going to look at strictly the number that's to the power of x. Okay, that's the only one we care about here. Is that number bigger or smaller than 1? Smaller, so it's decay. Now, the factor is always what's straight out from the equation, okay? Now, to work backwards and find the rate, here's what you have to do. You have to work backwards and do 1 minus whatever that factor is, which is going to give you 0.05. So this is also could be written as 5%. Okay, same thing. So if something's decaying at a rate of 5%, 95% or 0.95 of it is maintained. Okay. All right, so the next one. If this number is bigger than 1, it is growth. The growth factor is always whatever that number is, which is just 2. I put it as 2.0, and you'll see why in a second. So when we have a growth factor and we want to turn it into a rate, you are going to subtract 1 from it, which is just going to be 1. So this one's a little bit weird because there's no real decimals involved. So think about this as 1 represents 100%. And something's basically growing by 100 additional percent. It's doubling up. It's basically doubling. Okay, that's what that means when that's your factor. All right, so if that was a little bit tricky, the good news is the actual math is a little bit easier in my opinion. Just knowing how to use the calculator is a big part of it. So this formula right here, it's pretty much like a one size fits all for the most part if you know how to use it correctly, except for compounding continuously. So we're going to use this formula a lot, even though sometimes you can use the more simple formula. We're going to mostly use the more complex one because it works for almost everything. So what we're going to go through is identify all of the variables in the problem. So suppose you invest $500. If you invest $500, is that how much you're starting with or ending with? Starting with. Good. So your P is going to be 500. So P is always what you start with. In a savings account at Regions Bank that pays 3.5%. If something is paying, is it growth or decay? Good, growth. So since it's growth, I know that this is going to stay as a positive. If it were decay, it would change to a negative, okay? So that's going to pay. And then your rate is going to be whatever this percentage they give you is, but you're going to convert it to a decimal. Okay? Next one says annual interest. Annual means N is equal to what? 1. And how much will be in the account after 5 years? That represents T, which is time. So you see how we were able to identify all of the parts of that problem right ahead of time. Okay. So now what you're going to do is you're going to plug in. Now, some people were asking me in the last class about this, so I just want to be really, really clear. This is not A times T. This is like F of T. okay? Or f of x, it's a function notation. So when I write it, I'm just going to write it as a regular a, okay? I don't want anybody to get confused by that. So a is equal to p times 1 plus the rate divided by n to the power of n times t. So I just took everything that I knew and I plugged it in. Alright, so from here, I like to simplify as much as I can inside of the parentheses. So it's going to give me a equals 500 times 1.035 to the power of 5. So what you can do now with these calculators, you can go ahead and type this in, okay? So we have 500 times 1.035 caret 5, the power of 5 symbol. And what you're going to end up with is 593.84. So if you struggled with getting that in the calculator, as long as you understood up to that point, we can fix the calculator issue, no big deal. So don't worry too much if you're not getting it right. I can come and help you at the end. All right. So the next question is similar. It says a $2,000 loan has a fixed annual interest rate compounded monthly. After being unpaid for 5 years, the loan has a balance of, what is the interest rate of the loan? So, if the loan was taken out for $2,000, what letter does that represent? P. So it has a fixed annual interest rate, but it's compounded monthly. So n is going to be equal to what? 12. After being unpaid for 5 years, that represents what? T. The loan has a balance of, that's the final balance, which is A. And interest rate. We don't know what R is, but that's okay because we have a bunch of other variables to figure it out, right? So we're going to go ahead and plug in. So A is equal to P times 1 plus R divided by N times N times T to the power of N times T. So to solve this, I know I'm going to have to divide both sides by 2,000, but I want you to be careful. You don't want to do this in the calculator right away. You want to get everything solved for that variable you're looking for and then put it all in the calculator. Why would I want to do that as opposed to just doing it all right now? Yeah, exactly. Okay. So here's where things get a little bit tricky. I can't bring anything to the other side because it has a power on it, right? So do you guys remember back when we did exponents converting radicals to exponents and all that stuff? So to get rid of a 60 power, how could I get rid of a 60? What could I divide 60 by to make it 1? 60. So wouldn't that be the same thing as multiplying it by 1 over 60, that power? Would you agree with that? If I multiply 60 by 1 over 60, it'll become 1. But what I do to one side, I have to do to the. So if I put both of them to 1 over 60, that's going to get rid of that particular thing. So this cancels out. And this leaves me with this over here to solve. And then I have this. And then I'm going to subtract 1 on both sides. And then what should I do to both sides to get rid of the 12 and get r by itself? Multiply. Oops, I didn't mean to put the parentheses there. There it is. So I get r equals, well, r is going to be equal to all of this stuff. Okay. So I just want to say with the calculator, if you don't feel super confident in typing this all in one shot, you don't have to. What I like to personally do is I will type in this part first. I'll then subtract 1 from that amount and then multiply it by 12. So I don't have to worry about as many order of operations. So that's what I recommend. So I'm going to do 5663.6 divided by 2,000 equals, and I'm going to get some amount. And then I'm going to use that little caret button that we learned about yesterday on the left. And I'm going to put it to the power of parentheses 1 divided by 60. Got to put it in parentheses because you're putting it to the power of 1/60th. And you're going to hit enter. And you're going to get some number. I'm going to take that number and then subtract 1 from it. And then I'm going to multiply it by 12. And in the end, I'm going to get 0.21, which is about 21%. Now, this is actually growth and not decay. It came out to be positive. Why is this growth and not decay? The person's loan is getting what? Bigger. Okay. So if you guys are struggling with the calculator on this one, like I said, I'll come around and make sure you guys can figure it out by the end of class. Just want to make sure you have enough time to do that. All right. So this one here. What we're going to actually do, because I think this one is pretty similar to the last one. This one's pretty easy. What I want to do right now is I'm going to jump forward to number 6, and we'll come back to the other one. And I'll come around and work with you guys on that next question so you guys can get my help. So it says, Bruno invested a certain amount of money in a retirement account with an annual interest rate of this amount, compounded continuously. You guys see that phrasing? That tells me I have to use this formula. Okay. I mean, as if I didn't put it here, but you know, on the test it's not going to put it there for you. After 11 years, the balance in his account has reached, what was the amount of his initial investment? So, let's go through and identify everything we know. The rate is 0.0671. I know that it's compounding continuously, so I have to use that formula. T is equal to 11. And here's where the tricky part is. After 11 years, his balance has reached. Is that A or P? A. P only represents the initial amount. So we only know A, T, and R. So we're going to put in what we know into the formula. Now, E is not a variable. It's actually a number, okay? So what you actually want to do here is you want to isolate whatever variable you're solving for first. So I'm going to divide both sides by E to the power of all this stuff to get P by itself. This cancels out, and I'm left with P equals. So here's how you're going to type this into the calculator. Do you guys, before you hit anything, if you guys are using one of the fancier calculators, it's going to, I think, be like the third or second button down. It's going to be like a lowercase e. But if you're using one of these, it's going to be, if you guys see the second button on the left, do you count down where it says log and then it says ln on it? You see that button that says ln? If you hit, you can try it now, second ln, you're going to get e to the power of. Do you guys see that? Lowercase e to the power of. That's how you're going to use that button. Okay, so clear it out and we're going to type in the whole thing from the beginning. I just want to make sure you've all seen it. So you're going to type in 18200 divided by, you're going to hit second ln. You're going to get e caret parenthesis. That's where you're going to type in what e is to the power of, which is 0.0671 times 11. you're going to close those parentheses. Okay? Make sure you put the end parenthesis and then you're going to hit enter. And when you do that, you should end up with this. How'd you guys do? Good. All right, perfect. So what I want you guys to all do now is go ahead and try number 5 on your own. I'm going to kind of like quickly go through it, and then I'm going to walk around and make sure everybody's good with it. Okay? Yeah.